we're going to look at two more rules for exponents that we can use, and we're going to find their shortcuts. First, for our vocab, if we say a monomial, that means we have a single term. So that's what we're going to be looking at in this lesson, is monomials. And if it's a single term, that means that there's no adding or subtracting. So everything that we're doing in here with these exponent rules only work with multiplying and dividing. It wouldn't even work if we had addition or subtraction. So multiplying and dividing only. If the directions say to find the product, that is the answer to a multiplication problem. And if it asks us to find the quotient, that's the answer to a division problem. Okay. So let's go over the rules that we found, or the shortcuts that we found when we were doing this activity before this lesson. So for the product, that means we're multiplying. The shortcut is that we can add the exponents. I want to make a note before we do any of this, though, is that for all of these, it only works if the base is the same. So the base must match. If it does not match, then you cannot use these exponent rules. So for the product, you add the exponents. So an example would be x to the third times x to the second is x to the fifth. So the bases match, x, and the base stays the same. And you add the exponents. 3 plus 2 is 5. And then for the quotient, that's division. Our shortcut is that we can subtract the exponents. But that same rule applies, that the bases must match. So an example here would be like if I have x to the 10 over x to the second, that would be x to the 8th. So the bases matched, x and x, the base stays the same, x. But we can take our exponents, 10 minus 2, and we get 8. Okay, so let's use those rules to help us solve these problems. Number 1, the bases match, 5 and 5. And we keep that base the same. So the base is still going to be 5, but I can add those exponents. 3 plus 4 is 7. And then, because we know the 5 is the base instead of a variable, what we need to do is actually solve 5 to the 7th power. And we'll come down here and make another note. So in our calculators, how can we do that in a calculator? So we're going to type in the base of 5. Then we're going to hit the button that looks like this. It's called the caret button. And then we tell it what exponent we want, in this case 7. And you hit enter. Or you could just type 5 times 5 times 5 times 5 and do that 7 times. But when we do that, we tend to make more errors, and maybe we think we multiplied it 7 times, but we only multiplied it 6 times, or we multiplied it 8 times. So using this shortcut in the calculator makes it just a little bit easier, less likely to make mistakes. So then 5 to the 7th power, we put that in the calculator, and we get 78,125 will be our official answer, fully simplified. Number 2, I have 2 different things here. I have 2 of them have a base of 8, and 2 of them have a base of x. So remember, the bases have to match. So the ones that have a base of 8 can be put together and use our shortcut, and the ones that have a base of x can be put together with our shortcut. So let's do the 8s first. So we have 8 and 8, so the base is going to stay 8, but we can add those exponents together. 3 plus 2 is 5. And then we can do the same thing for the x's. So we're going to leave the base x. We have 6 plus 4 is 10. And then with the x, we're done. But with the 8, we can simplify it a little bit more. So then I would want to put in the calculator that 8, and then your caret button, and then you would tell it 5, and that's going to give us 32,768. But then we still have that x to the 10 that we don't want to forget about. Okay, number 3. The second 3 actually has a hidden exponent. If it doesn't show the exponent, it's because it's a 1 and we don't have to write it, but it is still there. So on this one, the bases match 3 and 3, so the base is going to stay 3. But now I can add those exponents. 4 plus 1 is 5. A common mistake I see is we forget to add the 1. And then we can simplify that further, so I'm going to type in the 3, the caret button, and then I'm going to tell it 5, and we get 243. Number 4, again, this 6 has a hidden exponent of 1. So the shortcut for dividing, we said, was we're going to subtract the exponents. So 5 minus 1, and again, I can do this because the bases match 6 and 6, so the base stays 6. 5 minus 1 is 4. So we end up with 6 to the 4th. So we need to do 6, hit the caret button, 4, and that's going to be 1,296. Again, bases match. So then the base just stays the same. Then we can use our exponent rule. 8 minus 6 is 2. Probably can do 4 to the second without a calculator. 4 times 4 is just 16. Before we look at the next one, I want to make sure we're understanding that. And all of these, notice that the base was 5, 5, it stayed 5. 8, 8, it stayed 8. So we're not actually multiplying 5 times 5 to get 25. We might do that at some point, but only after we've taken care of our exponents. So we're using adding the exponents to multiply these. Even though it doesn't seem like we're multiplying, we are actually multiplying. So we don't want to double multiply by multiplying 5 times 5 also. So the base stays the same when we're using these exponent shortcut rules. Okay, so let's look at number 6. Base is the same, x and x, so I can subtract. 3 minus 5 is actually negative 2. So now we got to pull in what we used from the last lesson. Can't leave an exponent negative, so we think of it as a fraction. And we need to take the reciprocal or flip it upside down. This is negative, it's in the top, so it needs to move to the bottom. So we end up with 1 over x to the positive 2. Okay, number 7, we're starting to put some of these together. This has a hidden 1 here. So these have a base of 4, so the base stays 4, and I can use my exponent rules. 7 minus 1 is 6. Then the y's have the same base, so then that's going to stay y. This is a 4. 5 minus 2 is 3. So we're subtracting our exponents. But then because we can actually do 4 to the 6th, so we're going to figure out what 4 to the 6th is. So then this simplifies to 4,096. That's 4 to the 6th. But then I still have y to the 3rd that I'm going to tack on to the end. Number 9. This is kind of a combination of the two rules, product and the quotient. So there's more than one way to solve this. I could deal with the a to the 3rd and a to the 7th, which is what I'm going to choose to do. Or I could do my dividing. So like we divided here in number 5, I could divide and do 3 minus 6. Or I can divide and do 7 minus 6. I don't want to do both. You just pick one or the other. So the way I feel more confident solving these is I like to think of the numerator and the denominator as two separate problems, at least at first, until I'm ready to do my division. So I'm going to look at just this top part. So those are multiplying. So this shortcut is to add the exponents. That becomes a to the 10th. So I haven't done anything with this a to the 6th yet. But now I just have a regular division problem. The base is a, so I can use my shortcut. 10 minus 6 is 4. And no matter which way you choose to solve that, you're still going to get a to the 4th.